Hello everyone, welcome to the solution of LeetCode problem 102 named binary tree level order traversal. In this problem, we are given the root of a binary tree and we have to return the level order traversal of its node value. And we have to do the traversal from left to right and level by level. Suppose it is a binary tree, the root is 3, the left children is 9, the right children is 20, and 20 also has two children. The left one is 15, and the right one is 7. Now, this is the first level. For the first level, it has one node 3, and for the second level, it has two node 9 and 20. And for the third level, we have two nodes 15 and 7. So we have to return this. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken this example. Here, the root is 5, which has two children, 3 and 6. 3 also has two children, 1 and 2. And 2 also has two children, 1 and 1. Now, the basic intuition behind the solution of this problem is we have to deal with the level order. Now, those kind of level order problem can easily be solved using the breadth first search algorithm. We can also solve this problem by using the DFS, which is depth first search, by only using a level variable here, but it is quite optimal to use the BFS to encounter this kind of level types of problems. So according to the convention, we will use the BFS algorithm to solve this problem. Now let's see how the algorithm works. Now we always know that the BFS algorithm utilizes the queue data structure. So we have used our queue here. Let's name it queue. And also we have used a vector which will store the level order traversal sequence. Now the start of the BFS will be at the root node 5. So we have to insert the root node 5 here. Now, what is the size of the queue till now? The size of the queue till now is 1. So here we have to insert the value of 5 into a vector and we have to remove the value of 5. But after removing, we have to check whether the 5 has the left children or not. Yes, 5 has a left children where the value is 3. And again, 5 also has a right children where the value is 6. Now, the first level we have calculated is 5. So, what is the queue size till now? So, here the queue size is 2. So, we have to insert again the first value 3 into a vector and remove it from the queue. Now, after removing, we have to insert the left children value and the right children value of the 3, which is 1 and 2. Now again, as the size of the previous queue was 2, so we have to consider 2 of the element, which is 3 and 6 for the second level. So here, again, now top element of the queue is 6, so we have to insert 6 here. Now we have to remove 6. Okay. So far so good. But 6 does not have any of the left or right children, so we don't have to insert anything into the queue here. So we have found the second level. Now, what is the queue size? Again, the queue size is 2, which contains 1 and 2. So we have to insert the value 1 into a vector, and 1 does not have any of the left or right children. So now we have to remove 1. Now we have to insert 2 into a vector, and 2 does have one of the left and one of the right children. So we have to insert both of them, which is 1 and 1. So we have found the second level and we have to remove the 2 as well. So it is the third level actually. It's my mistake. So for the third level, it is 1 and 2. Now, for the final level, the top element of the queue is 1. So we have to insert the element 1 here. Now again, we have to remove the 1, and 1 does not have any of the left or right children. So again, we have to check this 1. We have to again insert this 1 into a vector. And as it does not have any of the left or right children, we have to simply remove it. Now we have seen that our queue become empty. That means we do not have any of the remaining node into the queue. And our sequence is this. So we have built this sequence, and this is basically the level order traversal sequence of this given tree. And this is how basically the breadth first search algorithm works. And overall time complexity of this problem is big O of n, where n is the number of nodes. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named level order, which has a root as a parameter. Now we are taking a vector of vector as a to store the answer. And here, if the root is null, we have to simply return the answer, which is an empty vector. Otherwise, we have to take a queue which contains the tree node value named q. Now we have to insert the initial root to the queue and make the current as the root. Now we have to run a loop until queue is not empty. And in each iteration, we have to calculate the queue size, and we have to run a loop to 0 to the queue size. And here we are declaring a temporary vector current. Now we have to store the front element of the queue, which is a root, into a node x, and we have to remove it by using the queue pop, and we have to insert the corresponding value of this front node to the current vector. And here, if the current front node has left child, we have to insert the left child, and if it has the right child, we have to insert the right child into the corresponding queue. Finally, after this inner iteration, we have to insert the temporary vector current to the answer vector. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.